All right, good morning, everyone. This is the April 2025 Water Conditions Monitoring Committee. My name is Emily Adrid, and I'm with the Colorado Water Conservation Board. And today we have presentations from the Colorado Climate Center, NRCS, and then we have the Colorado Department of or Division of Fire Prevention and Control with us today to provide an update on wildfire outlooks for the next few months. So with that, I will hand it over to Peter with the Colorado Climate Center.
Yeah, good morning. Good morning, Emily. Can you hear me?
Yes,
All right, perfect. Let's see here. And are you seeing my screen in full screen mode?
I am. Yep.
Perfect. Well, good morning, everyone. For those who may not have met me, my name is Peter Goebel. I'm the Assistant State Climatologist with the Colorado Climate Center at CSU, and I'll be taking us through a little tour of the recent weather and climate conditions that we have been experiencing around the state, and then giving us a little bit of a look forward at the outlook for the next several months. After that, we'll go over to NRCS, who I'm really looking forward to hear from today because we're at that time of year where the snowpack has just peaked and is starting to melt, and it's always interesting to see what's going on with our water supply this time of year. So this is kind of our normal agenda. We're going to go over some facts and figures, looking at seasonal climate conditions, look at some notable events that occurred over the last couple of months, mainly the last month, and then we'll do an update on drought conditions and end with the seasonal forecast, looking at how things might be shaping up going forward. Okay, so this is a look at one of our what we call quadrant charts for Colorado for the month of March. Now, this product uses data from the National Centers for Environmental Information and Climate Grid product, which is a gridded 5-kilometer resolution daily temperature and precipitation data product. And we're averaging those data across the state of Colorado. And this uses all years going back all the way to 1895. If you have any questions about how these graphics are put together or how we get that kind of data, I'd be happy to answer those later if you follow up, because we use the NCLIME Grid product for so many of our updates. But if we look at this graphic on the horizontal axis, we're looking at precipitation. The vertical axis is temperature. Each year shows 1 year in that historical record from 1895 to 2025. And then the crosshatches you see show the average temperature for March for 1991 through 2020, or our most recent 30-year climate normal. And the vertical crosshatch shows the normal precip for March across the state. And that star, you see 2025 in the upper left-hand corner, we're in what we call the warm and dry quadrant, 2.6 degrees above our 1991 through 2020 normal. More than that, if we look at the whole climate record going back to 1895, and then a little bit below normal for precipitation. Here's how that shook out across the state. Okay, these graphics are a little bit different than what I've shown at WCMC before. So usually what we do is we just show the ranking across the state using the whole time series. Instead, I'm really just looking at the differences from the 1991 to 2020 normals. And the reason that I'm doing that is just because I don't want to keep mixing time scales that we're comparing to, where in one slide I'm looking at the departures from that most recent 91 through 2020 normal, and in other slides I'm looking at the full record. If you want to see the ranking maps, they are on our website, or I can talk about them more. Furthermore, if you look at the legend at the top of this figure, it shows not just the departure from normal for the 1991 through 2020 average, but also the 20th century average, or 1901 through 2000, which you can see is much different. Where if I was showing the departure from the 20th century average, this whole graphic would be showing red because we were 6 degrees above that average. But this gives you a better idea of how things have compared to our recent normals spatially, where it was a mild March on the eastern plains, but for our high country, it was much closer to our recent normal. If we were to look at the whole time series going back all the way to 1895, it was the 10th warmest or 10th most mild March in that record. And if we look at a historical time series averaged across the whole state of temperature, this is what we see. And it is the warmest March that we've had since 2017. We've actually had some cooler than average Marches recently, but this was definitely on the warmer side. 2023 really sticks out as a recent cool anomaly with March. Okay, similar to temperature, this is a look at percent of normal precipitation with respect to that 91 through 2020 normal. So we were just about 2/10 below. I think I actually had on another slide that's a little less than 2/10 if you're going to the nearest hundredth, a little bit less than 2/10 below normal statewide. But there were some definitely some you could say haves and have-nots on this map. So, for instance, on the Northern Front Range, we were well below normal for precipitation in March up until the last couple days of March, where we squeaked in a nice rainstorm right at the end of the month, putting some parts of the state, or some parts of the Northern Front Range rather, at or even a little bit above average. Denver still a little bit below. Some parts of the Eastern Plains, if we look out towards Kit Carson County, did well for precipitation, as well as parts of Lincoln, Elbert County. If we look at the Arkansas River Valley, though, really zeroing in on Fremont and Pueblo counties up into Chaffee and Park counties, we had some areas that were much drier than normal. I do want to point out the southwest portion of the state as well, near to a little bit below normal, and we really needed March to deliver in southwest Colorado because conditions were so much below normal for December through February, and now we're getting into the point of the year where we're getting into the dry season in southwest Colorado. So those below normal precipitation and snowpack conditions are probably locked in now for southwest Colorado. You know, we could end up with a good monsoon, which certainly helps with fire suppression, not as much with our water supply, but the below normal water supply probably locked in at this point. You can't count on a miracle May like we got in 2015 every year. Okay, March precipitation, driest statewide since 2018. As I showed on the last slide, there certainly were haves and have-nots around the state. But overall, for most of southern Colorado and a lot of southern and western Colorado, it was a drier than normal March. It was also a windy March for a lot of us, and that's not particularly unusual for this time of year, particularly under La Nina conditions. La Nina has officially gone away. I'll talk a little bit more about that later. But springtime is our windiest time of year, and La Nina springs on the eastern plains tend to be windier than normal springs. This is just one example of wind gusts from our Colorado Agricultural Meteorological Network stations from March 4th, where you can see down in the Arkansas River Valley, we have gusts of over 50 miles per hour, even 60 at that Holly 02 station. And it's important to keep in mind when looking at these wind gusts numbers that typically we measure gusts at 10 meters, and these stations are only 2 or 3 meters above the ground. So you really, to get more of an honest 10-meter wind gust number, need to multiply these numbers by roughly a factor of 1.2. So some of those areas where you're seeing 55-mile-an-hour gusts, those are probably truly more like 70-mile-an-hour gusts at those 10-meter wind towers that we typically measure gusts at. These numbers are even higher. So this is looking at our March 18th windstorm. And we can see that down again in southeastern Colorado, we had some gusts upwards of 65 miles an hour, which if you're multiplying by that factor of 1.2, you're getting closer to 80, 85 miles an hour. Gusts got even higher up in the Texas and Oklahoma panhandles. This is a satellite image that where a filter's been used to really point out dust. That area of yellow that you see is a corridor of dust from this March 18th going into March 19th storm. Of course, in this image, this beautiful image, the dust is further out into the south central US, but dust did affect parts of the far southeast portion of our state before it really got whisked out into more the central portion of the contiguous US by this storm. In fact, we had some of our lowest sea level adjusted pressure readings from the storm on record in southeastern Colorado, not as low as our bomb cyclone that you might recall from March 6 years ago, but still some of our lowest on record. And then this is a count of days with red flag warnings from the National Weather Service in Pueblo through the middle of April. And you can see 2025 in the light blue. The graphic shows accumulation for a full calendar year. So if you look at the far right hand side of the graphic, you're seeing accumulations all the way through December. But one thing you'll notice if you look at that March and April timeframe is this really is the time of year where we have a lot of wind, and a lot of times things haven't really greened up yet on the plains. That puts into play some detrimental fire weather conditions, and we've had red flag warnings, potential fire conditions for many days in March and April, which isn't necessarily unusual for southeastern Colorado, but we are on the high side of that historical distribution. This is a look at departure from normal temperatures, again using that 1991 through 2020 normal for the month of May, almost through the current day, just for the first 20 days of the month. And you can see that overall conditions, temperature-wise, pretty near normal. We have really oscillated about that mean, though. We started the month of April much cooler than normal. That first week of April was cold, but then we had record warm conditions across a lot of the state the second weekend in April before reverting to cooler conditions just before Easter last weekend. And this is an example of some of the warm conditions that we experienced in April. These are high temperatures using, again, the Colorado Agricultural Meteorological Network for Saturday, April 12th, 2025. And all across eastern Colorado, we got into the mid 80s or higher, 70s, upper 70s, even some 80s on the west slope, where that kind of heat is maybe even a little bit less common this early in the season. Certainly becomes more common later at lower elevations, but yeah, overall, a lot of records set across the state, at least daily records in terms of temperature. You can see again that Holly O2 station out in Prowers County that I pointed out earlier for the exceptional wind speeds that we saw in March, 97.2 degrees. So pretty exceptional temperatures second week of April. This is a look at snowfall measurements from our latest snow on Saturday morning. These were snowfall measurements from the Community Collaborative Rain, Hail, and Snow Network. You know, in the Denver metro area, for folks who are in that area, you maybe saw a few inches of snow on the ground that morning, perhaps even higher if you're in the foothills. But where we really got hit harder was some areas down near the wet mountains like Fremont and Custer County up into Chaffee County. Those were areas that were really going backwards from a drought standpoint. So this was very welcome moisture in those areas to receive upwards of a foot of snowfall. Okay, this is a look at, I have just a couple graphics showing the last 3 months. So this is January through March, the first quarter of the calendar year. Again, this is a look at a quadrant chart similar to what we showed for just March. where the cross hatches give you your normals, horizontal axis gives you precipitation, vertical axis temperature. Each bubble represents an individual year, and then the star is 2025. So we've been dry for the first quarter of this calendar year. We were a little bit on the cool side of recent normals for the first start of the calendar year. Both January and February were a little on the cooler side, even though we had a milder March. If we look at the first half of the water year, so if we include October through December in these calculations, then we're back in that warm and dry quadrant because we did have a warm start to the water year, even though January and February were cool. All right, and then similar to just March, this is a look at kind of how things rank across the state or departure from normal temperature across the state, where we see that the cooler than normal conditions more focused on the eastern plains, particularly with some of the cold that we got in February, warmer than normal in the San Luis Valley and parts of the west slopes. And then here's a look at the time series where you can see while there's an upward trend in the numbers long term, if we look at the most recent 30, 35, even as much as almost 50 years, pretty on track with recent averages for January through March, average statewide temperature-wise. Here is a look at the first 3 months of the calendar year precipitation-wise, and we can see where droughts really developed more is in southern and western Colorado. Some areas looking a little bit better on the eastern plains and northern Front Range. And then precipitation wise, again, it looks like we're the driest statewide since, let's see, I believe I'll have to double check, but I believe, yeah, that's got to be 2018 is the last one that was drier because that big spike that you see in the, I don't have it labeled, but that big spike that you see in the graphic after 2018 or after that last big dip there is certainly 2019. So it's got to be the driest that we've seen since 2018, unless there's another little data point hiding between the dip and that big spike, and it would be the driest since 2017. So we'll call it 2017 or 2018 there. And then just a couple graphics real quick, looking at the last 12 months. So this is April of 2024 through March of 2025. So the last full 12 calendar months. And we see that temperatures have been warmer than our recent 1991 through 2020 normals across the state, with a few exceptions where we're very close to normal, but on the cool side of normal, and over the higher terrain of western Colorado. Overall, those 12 calendar months are the second warmest on record, average statewide for any April through March period. And then this is the same thing for precipitation. You can see if we go back all the way through last summer that there's still an area of higher than normal precipitation in the San Luis Valley, where they had a really good late spring, early summer last year, but more areas than not on the drier side of normal over the last 12 months statewide. All right, let's see here. Before I get into the drought update, I was putting together a slide. I was a little pressed for time, didn't quite get to it, but I'd really like to put a slide up showing snow totals for the snow season to date, going back to last September through as far as we are in April across the state, because certainly some areas, we'll talk more about the snowpack with NRCS in just a moment, but if we look at some of our lower elevation snowfall totals seasonally across the state, I know that it was right about 33 inches snowfall to date in Denver at Denver Central Park, which is the lowest since 2018. Similarly, we're in the upper 60s in terms of accumulated inches in Boulder, which sounds like more, but of course Boulder gets more snowfall, so that's also the lowest since 2018. Up here in Fort Collins, we're at 25 inches of snowfall for the snow season to date. the least since which is the least since 2011. So definitely on the low side of now I'm checking myself. I'm like, I may have said most, I meant least when I was saying since 2018. Least since 2018 was for both Denver and Boulder, and then the least since 2011 for Fort Collins. I'd love to look at some of those numbers on the West Slopes as well, like Grand Junction, Walker Field, and some of those longer term legacy weather stations, and see where we're stacking up. Maybe get that slide in this presentation before we put it in a PDF and put it on the CWCB website. Um, we'll talk a little bit more when we get to the outlook about whether or not we should expect to see more snow. But for the drought update, drought development certainly across the southern and western portions of Colorado in recent weeks and months. Modest improvements over northern Colorado. We do have some areas where soil moisture is higher than normal, some areas where that's good, some areas where that's bad. I'll talk about more in a minute as well. Oh, here's my snow slide. So I thought I'd included it. This slide's incomplete, but I thought I'd included it a little bit before the drought update instead of right after. Okay, so here is our current US Drought Monitor map. This map will be updated on Thursday. And while I can't give early releases of USDM officially to the media, you might expect that with some of the snow that we had in areas like Custer and Fremont and Chaffee County, that some of these areas could potentially see improvement on the US Drought Monitor map with the recent snow that we experienced. But we're seeing at least 55% of our state is in D0 or abnormally dry or worse on the US Drought Monitor. You would expect in a normal year to see 30% in D0 or worse, but we're at almost double that. Looking at D1 or worse, we're at 37%. One piece of good news, very little extreme drought and no exceptional drought on the US Drought Monitor map right now. Where you do have the extreme drought kind of over in that Wolf Creek Pass area. You may hear more about this from NRCS, but I believe that Wolf Creek Pass peak snowpack this year was the lowest since 2002. For most areas in the mountains, the snowpack, if it was on the low side this year, was more likely to be lowest since something like 2018 or 2012, one of those years, but lowest since 2002 for the Wolf Creek Pass station, which is pretty alarming to see. Some of our areas further in the northern Rockies, we were closer to normal, so that's where you're seeing areas that we don't have drought on the US Drought Monitor map at this time. We've talked a little bit about conditions over the last 3 months. This is how conditions have changed on the US Drought Monitor map over the last 12-week period. So January 21st, 2025 through April 15th, 2025. We can see that there's been, again, some modest improvements in northern Colorado, but on the whole, definitely more degradations in southern and western Colorado. And then this is how things have changed over the last year. So comparing April 15th, 2025 to April 16th, 2024, a couple small areas or a couple areas where there's been small improvements, pretty large spatial area where you've seen improvements on the Eastern Plains, but overall more degradations than improvements. This is a map showing soil moisture, top meter soil moisture percentiles using a high resolution version of a NASA land surface model that integrates data from satellite in order to make the depiction. Areas in the greens and blues are where you have above normal soil moisture. Areas in the warmer colors that match the US Drought Monitor, as you would expect, are where you have below normal soil moisture in that top meter. A couple points I want to make here. First off, local conditions may vary. So just because you have much of eastern Colorado showing above normal soil moisture if we have any ag folks listening, just because this map shows above normal soil moisture does not necessarily mean that's true on your field. Uh, Also, soil moisture models tend to vary more than, say, estimates of temperature, more than different, certainly more than differences across data products for temperature and precipitation. So, you know, you can kind of take these with a grain of salt sometimes. But I was at an ag conference last week where folks on the Eastern Plains that I talked to were generally feeling pretty good about their soil moisture going into the growing season, better than in a lot of recent years, but are certainly concerned about what could happen in the coming month or two, since this is really, we're getting into the crucial time of year for receiving moisture on the eastern plains. Whereas, as I talked about earlier, on the west slopes and in the high country, we're transitioning out of that time of year where, especially for southwestern Colorado, once you get out of April, May is really getting into the start of the dry season rather than the peak of the wet season as it is for the eastern plains. Um, Another point I want to make here, you see this mixed signal between lower than normal soil moisture in some of our valleys in western Colorado and higher than normal soil moisture over some of our mid to high elevations. I would consider that whole pattern a dry signal because this is the time of year where at those mid to high elevations, if you have higher than normal soil moisture, that is most likely indicative of earlier than normal snowmelt. The one exception I would make there is the higher than normal soil moisture you see over the lower elevations of the San Luis Valley. That may be a footprint from the wetter than normal conditions experienced last summer. This is a terrestrial water storage percentile map, which is an integration of snowpack, soil moisture, and groundwater. And this is a newer product that we're still learning about. So I don't necessarily want to induce panic with this product, but just the integration of certainly snowpack at higher elevations and groundwater at some of those lower elevations, particularly up in northeastern Colorado, where you have things kind of stretching into the Ogallala Aquifer, are considered much lower than normal by this product. Again, this is a newer product that we're kind of learning about. So I don't really want to stamp my foot in the ground here and say conditions are really bad. Look at terrestrial water storage. But this is just another interesting source of data that we want to start integrating into some of our updates. All right, so that does it for the drought update. With that, I will go ahead and transition into our kind of tail end of spring and summer outlook. We'll start with just the next 7 days of precipitation. So here we're looking at the forecast for Tuesday morning through of this week through Tuesday morning of next week. Well, it's in UTC time, so it's really yesterday evening through Monday evening of next week. But the areas in the blue green are where the forecast from the NOAA Weather Prediction Center has us receiving above normal moisture. Areas in brown are below normal moisture. And the upshot here is that it looks like it's going to be a below normal moisture week for the Rockies and the West Slopes. Kind of a mix on the Eastern Plains. It looks like over the next couple days, particularly Thursday and Friday, we may have some opportunities for some afternoon showers that really extend out onto the Eastern Plains and probably affect that area most. But it doesn't look like we're going to have any good moisture coming across in terms of like a good strong cold front that really brings another layer of snow to the mountains. Here's the 8 to 14 day time frame. CPC Climate Prediction Center showing an increased probability of above normal temperature. That's what you're seeing on the left-hand side of your screen. An increased probability of above normal moisture. The climate or the weather prediction models that I've looked at for this time frame are pretty scattered. So I'd be reticent to bet too strongly on any of that. If anything, what I was looking at showed that maybe I'd bet a little bit more strongly on that temperature signal west of the divide than east of the continental divide. Uh, so we'll see what happens there. When it comes to moisture, yeah, it looks like things are gonna be kind of unsettled across the central U.S. in general over that 8 to 14 day time frame. I would bet on some sort of good weather system or two moving across the central U.S. over that time frame, kind of tail end of April into first week of May. Models are all over on whether that moisture is really going to hit Colorado or not. Some of them have that moisture going north into Wyoming and Montana and us getting the wind again. Some of them have us getting a shot of cooler air during that time frame, but the moisture not really getting wrapped into the weather system until you get further out to the east. And some of them give us a really nice spring rain. So chance of a good spring rain. It doesn't look like we're going to be, under high pressure, stable, clear weather conditions per se, but the moisture is certainly not a guarantee for that time frame. Once we move beyond 8 to 14 days, of course, our numerical weather prediction models descend into chaos. And so we have to look at slower moving elements of the climate system and the statistical relationships between things like sea surface temperature patterns and weather patterns. And so this is a look at sea surface temperature anomalies across the globe. And here we're focused in on the center of our screen on the Pacific Ocean. I want to draw folks' attention to really smack dab in the middle of this picture, the equatorial Pacific Ocean. When you're seeing blue colors here, that's indicative of La Nina, more of the reds, El Nino. La Nina was in place over the last winter, but it's really broken down. You still have a more than active cold current kind of coming off of the coast of Baja California there, stretching out over the central Pacific Ocean. And that's kind of remnants of La Nina. And that's one of the reasons that I think that these seasonal models tend to lean towards us experiencing some lingering La Nina impacts, is because of some of those colder than normal sea surface temperatures still in place on the northern side of the equatorial Pacific Ocean. Before we get into that, we'll take a quick look at what La Nina means for Colorado, focusing really on the upper right here. This is a correlation analysis between El Nino versus La Nina and precipitation in Colorado. The upper left-hand corner is for meteorological winter, or December, January, February. Upper right is for spring, March, April, May. Lower left is summer, June, July, August. And lower right is fall, September, October, November. Areas where you see the red colors are where we tend to be wetter during El Nino. Areas in blue are where we tend to be wetter during La Nina. As you can see, if you look at spring, typically El Nino springs are, we get a little bit better shot than La Nina springs. None of this is guaranteed. So I like to use the analogy of playing a game of poker with a deck of cards that's stacked one way or the other. So if we're thinking about spring and precipitation in Colorado, perhaps we're playing the game without a couple of the aces in the deck and one of the kings in the deck. Deck might be stacked against us, but you could still get a killer hand. Similarly, if we had El Nino conditions, the deck might be stacked in our favor, but it's possible to have a dry spring during El Nino. So right now we're in neutral conditions. This is a graphic showing the probability of El Nino versus La Nina versus neutral going forward. For March, April, May, you see near 100% neutral. and it's likely that neutral conditions will remain through at least the midsummer. Once we get out into fall, it's really anyone's bet. But these, as I mentioned, if we when we get into the graphics from the Climate Prediction Center showing the seasonal outlook for temperature and precipitation, I want to emphasize that even though we have neutral conditions, some of this is based on the anticipation of kind of lagged La Nina impacts, as La Nina has just broken down, but the atmospheric pattern can take a little time to respond. And with some of the remnants of that La Nina pattern over the sea surface temperature, that may be especially true this year. It's a weaker leg to stand on than if we just had a clear, strong La Nina. But there's still, if we look at some of these models, and in anticipation of lagged La Nina impacts. So with that in mind, here is the seasonal temperature outlook and precipitation outlook. Temperature on the left, precipitation on the right for May, June, July of 2025, as issued by the Climate Prediction Center last week. If we look at the right-hand side, anywhere in the oranges and reds is an area where we have an increased probability of above normal temperatures. Anywhere in the blue, which you don't see on this map, would be increased probability of below normal temperatures. If we look at the right-hand side of the screen, we see that there's areas in brown, we have an increased probability of below normal precip, and areas in green, which we see on the East Coast, increased probability of above normal precip. In both cases, if you see an area in white, that indicates equal chances, or as we like to call them, equally clueless. If we look at the temperature side of this graphic, we see particularly in southern and western Colorado, there's an increased tilt towards above normal temperatures. This is based not just on lagged impacts from La Nina, but also trend in recent years, particularly as we get into summer. The interannual variability in temperature in summer is relatively small compared to the overall trend towards warmer temperatures, whereas that's not the case in winter and spring, where the interannual variability in temperature from year to year is quite large and still certainly large with reference to even the trends that we've been seeing. When we get to the precipitation side, this is based on a couple things: the increased tilt towards below normal temperatures. So we do have La Nina, the lagged impacts of La Nina factoring in here, particularly for the first portion of this forecast, May into June. We also have a little bit of trend if we were to look more to the north and west of Colorado, like up towards Moffat County. That area has trended a little bit drier in recent years on the kind of this 3-month May, June, July timeframe. And then there's also this component reading into CPC forecast discussions of kind of the dynamical seasonal models that really try to simulate seasonal weather conditions are showing an increased probability of this warm, dry dome of air developing over summer time for the northern and kind of central portions of the country that may kind of affect the northern and eastern portions of Colorado. We hope that doesn't come to fruition, but reading into these discussions, I think it's one factor that's kind of leaned into why we see a forecast towards an increased probability of below normal precipitation. And you can see that more clearly when we look at June, July, August into summer. The one thing that's different here in June, July, August that I wanted to point out versus May, June, July is we really get more into that equal chances regime for southern and western Colorado because we still do a very poor job of seasonal forecasts for monsoon season precipitation in southern and western Colorado. So as we get into this time of year, we're often throwing up our hands for that July, August timeframe, late June through even into September timeframe for the southwestern US, including South and West Colorado. This is July, August, September. This is getting into the fall season. I don't want to spend too much time here. Let's just go to our takeaways here and wrap up. So March was warmer than our recent normal, certainly warmer than our long-term averages, more mild than normal. But if we think about what happened in January, February for the first chunk of the calendar year, we're still off to a little bit cooler than normal start of the calendar year. Also off to a drier than normal start to the calendar year and the water year for most of the state. There's some exceptions in the Northern Rockies and Eastern Plains, but overall drought conditions have worsened or advanced for much of southern and western Colorado. Along with the warm and dry, we've definitely had the wind on the Eastern Plains, as I demonstrated in some of our wind gust figures, as well as the figures showing, let's see, the dust storms and red flag warnings for southeastern Colorado. And then if we think about the outlook, La Nina is gone. We've given way to neutral conditions. However, La Nina is correlated with drier than average spring conditions and a much lower risk of a wet extreme. So that factors into some of our seasonal forecasts. And then as we get into early summer and, well, summer in general, we see that summertime outlook still favors warm and dry, but not necessarily because of La Nina. It favors warm because of recent trends, and it favors dry not just because of La Nina, but perhaps even more because of what some of these dynamical weather forecast models are showing for the summer season. So yeah, thanks, and let's keep in touch. And if there's any questions and if we have time, I would be happy to field those now.
Great, thank you. Whoa, great. Thank you so much, Peter. I think we had a question in the chat about one of your precipitation maps, and I was able to put a link in the chat, and so was Allie from the Colorado Climate Center. So if anybody wants to refer to those links, they're in the chat. Any questions from the audience?
So I am seeing in the chat that they were specifically referencing the snowfall image, and so that was from CoCoRaHS, not COAGMed. So I will go ahead and put a link to the CoCoRaHS map in the chat as well. But those COAGMed maps I also think are really cool. So I'll just throw that up there real quick, and yeah,
great.
Thanks.
All right. Thank you again, Peter. That was great information, especially looking at the outlooks into spring and even summer. I think that's helpful information. So thanks again. And we can move on now to NRCS. I think we have Nagam on the line. So feel free to share your screen.
Yeah, thank you, Emily. Can you hear me all right?
Yes.
Awesome. And can you see my screen?
Yes, we can see your slides. Yep.
Okay, cool. Awesome. All right, yeah. Hi, everyone. I am Nagam Bell. I'm a hydrologist with the NRCS Colorado Data Collection Office. And I'll be presenting on conditions for the NRCS today. Brian DeMoncos is the supervisor. He typically leads these talks, but I'm stepping in for him today. All right, so getting into it. This is a snapshot of statewide conditions for the 1st of April compared for this water year compared to last year. And then I pulled some numbers on April 20th after this Easter weekend snowstorm. So as of April 20th, statewide snow water equivalent is at 80%. So down from 86% on April 1st. That's also a notable drop from last year's 111% at this time. Water year-to-date precipitation is at 98%, so close to normal, though recent moisture has slowed. We're seeing a declining trend in short-term precipitation, so 30-day and 60-day values have dropped to 80 and 79% respectively, compared to over 100% just a few weeks ago. Median stream flow forecasts remain at 86%, a slight decrease from last month, which was at 88%. So again, that's reflective of early snowmelt and declining snowpack. Soil moisture values are holding fairly strong, with 20-inch depths ranging from 56 to 149 and 8-inch from 67 to 119. On the right side of the screen, the map shows record low SWE values across the state, with several sites in southern Colorado currently observing either their lowest or second lowest snowpack on record. And I don't have the names listed here, but some of those are like the Mancus Snowtell, Shark's Tooth, Cascade. And if you go over to like the Upper Rio Grande region, where's my pointer? Like in this region over here, that's the Upper Rio Grande, the Upper Rio Grande, you have Lily Pond, Wolf Creek and Upper San Juan. I don't know that they made it to the second lowest or lowest, but they are certainly down there, unfortunately. And so this graphic was from April 18th. So I'm here, this is a comparison for current snow water equivalent conditions to this time last year, statewide, on the left side of the screen. So statewide conditions are at 80% of medium as of April 20th, with most basins showing pretty notable declines compared to 2024. The southern basins, especially the combined San Miguel, Dolores, Animas, San Juan, and the Upper Rio Grande are particularly low, so both around 40, 44, and 46%. So yeah, showing massive declines compared to last year, which was at 84 and 85%. The Gunnison and Arkansas are also significantly below median, while the northern basins like the South Platte and the Colorado headwaters are closer to normal. Over here, the SWE map reinforces that disparity between northern and southern basins, with the warm colors in orange and red highlighting those drier conditions in the south, and then the north indicating closer to median values. And then this is just the percent change relative to normal. Okay, so here, this is on the top plot. This is our AWS snow water equivalent for the state of Colorado. So this shows just accumulation over the year. And then the bottom graphic is daily average temperature for the state. So on the top part, I highlighted 2018 and 2015. 2018 is that pink line right here. And then 2015 is the blue line, and the black line is our current water year. The green is median. So that black line is well below median for the state, and kind of dipped below 2018 levels in some, in this portion here. And then at the end of March, we had some early snow melt, which can be correlated with this air temperature graphic down here. We have a spike in air temperature here, and then, snow melt at the end of March, and then after peak SWE around April 8th, which kind of wasn't too off. I think it lined up pretty closely as far as that median peak date goes. But after peak, snowpack has started to melt, which correlates with these rising temperatures on the bottom graphic. And then, yeah, so as of April 21st, statewide, we're in the 8th percentile in this red shading here on the plot. And at 71% of median, this number here is for the average, the period of record average. That's why it's slightly different from that 80% number I provided earlier. Here, excuse me. So this slide shows snowpack by elevation and highlights the current snow density. So that provides, an insight into melt readiness. The top panel here is for statewide densities, and the bottom panel is just a zoomed in version for the combined Southwest basins. Just a reminder that elevation is a key factor in snowpack retention. But density is crucial for interpreting melt point potential. So if you go down to the bottom here, I highlighted a couple points. I know specifically that these have already melted out, but with the Easter weekend snowstorm, they got a bit of a dusting. So they were showing higher densities, but there's next to nothing as far as snow goes there. So like Mancos, there's 0.5 inches of SWE, and the density is showing 25%, which is, usually 25% density shows it's not indicative of like being a ripe or isothermal snowpack, but there is, the snowpack there is pretty ephemeral and ripe, so it'll melt out today, if not in the next couple days. Lone Cone, similar situation. It's got 0.2 inches of SWE, 10% density. So yeah, just wanted to be mindful if you use these graphics just to zoom in on some of these sometimes to look at exactly what's going on. But overall, we can see the general trend is in this like pink to peach coloring, which is in the between like the 40 to 50% range. So going isothermal and ready to melt out here soon. Excuse me for just 1 second, I have to cough. Okay, thank you. So here is a percentile image compared to the period of record. This is useful just to show like exactly, how low or high snowpack might be throughout the state. 33% of sites fall within the lower 15th percentile. So that's that red coloring we're seeing largely in the southern portion of the state, starting in like the Gunnison Basin here. In the southwest corner, Upper Rio Grande in Arkansas, and then there's even some in like the Colorado headwaters, and this even a point up here. 22% of sites. Oh, and then I should also mention, so with the sites that are in that lower 15th percentile, they rank in the minimum 1 to 7th place as far as their period of record goes. And that record ranges, as low as 9 years up to 47 years for these snow tells. 22% of sites are within 15 to 20, between the 15th to 28th percentile. 26 fall in that yellow shading, 29 to 42 percentile, 12% in that green coloring, and the number gets smaller as we go up. So 5% above average in that the teal or light blue color, and then 2% between 71 to 84%. Okay. Here I wanted to highlight one of our newer products. This, I didn't add a QR code, but you can access it from our National Water and Climate Center webpage under Site Tools Data Generator. There's a little mobile icon next to it because the goal with this tool is to be mobile friendly, so it's just easy to look at on your phone. So here I have an image of snowpack temperature at Red Mountain Pass. Red Mountain Pass is one of our super sites. We have a few super sites within our network, and what that means basically is that there's the standard sensor suite snow water equivalent precipitation air temperature, and then in addition to that, there's extended sensors. So here I highlighted one of those, which is that beaded stream cable, which takes snowpack temperature every 8 inches. So this is useful just to see exactly, when the snowpack is going isothermal, we can see it's trending in that direction. The 47-inch sensor is kind of mimicking an air temperature profile, so indicating that it's not buried anymore, but all the other buried sensors are near zero, with the one point we're at closer to 32 degrees. But with the recent storm, the 39-inch has gotten a bit colder, so not quite ripe. Median meltout date for this site is June 10th. Okay, here is water year-to-date precipitation. So statewide, we're at 98% of median. Again, seeing that clear distinction between northern basins and southern basins. And on the left side of the screen, I just highlighted, exactly how that departure from normal for each month starting in October. And March was the closest to normal, so definitely increased precipitation for March, particularly for southern basins and even more so for the southwest corner of the state. April, just the comparison is incomplete here because it's comparing it to the whole month of April, and I only had data until the April 20th, so just be mindful of that. But yeah, so March and February closer to normal, and then as we know, December and January we had little to no precip in some basins, or very minimal. So for month to date precip, and the month to date precip graphic is on the left side of the screen, and then 30 days is on the right. So month to date precipitation is at 88% of median as of April 20th, and then 30-day precipitation is at 80%, and that is for the period of record median on April 20th. We can see for the month to date precipitation that, again, that southwest corner benefited the most, and then along with southern basins, Arkansas at 95%, Upper Rio Grande at 105, and the Gunnison 74. For the 30-day precip, numbers aren't as elevated as that month to date, but yeah, ranging from 64 to 80% in the southern half, and 72 to 89 in the northern half of the state. Okay, here is a precipitation accumulation graph for the San Miguel for the combined Southwest Basin, and then the bottom graphic is the same thing, but then it also has projections for precipitation. So again, here I highlighted some comparison years, 2015 in that blue coloring, 2018 and that pink shading, which happens to be a record low year, and we are not close to that, fortunately, in the Southwest region. So that's encouraging. The black line is our current water year, so we can see that it's clearly below median, but again, not down to 2018 levels. If 2015 were to play out, then we could potentially, or just comparing to 2015, there is a potential for increased precipitation in May, which will likely fall as snowfall if temps aren't too warm, and we could see that happen in 2015 here, and that pushed accumulation closer to normal, and then above normal at some points, and then towards the end of the water year wasn't quite at normal but closer to it. So while that's not helpful for agriculture as the primary growing season has passed, it is great for soil moisture and runoff efficiency for the next water year, and then reservoir storage going into the next year as well. So looking at projections, if 2015 were to play out, then that would have to mean that we'd fall under the 90% projection. So rather wet conditions, and well above median. Yeah. Again, this is the same graphic for precipitation accumulation in Upper Rio Grande, and then the forecast accumulation or projection for the Upper Rio Grande as well at the bottom. So the highlighted years here for comparison are 2020 in purple. We're kind of close to that at the moment. And then 2018 in that pink shading, so well below what we're at now down here. And then 2015 in this blue coloring, which saw similar uptick in precipitation at the end of April and beginning of May period. Projections, so that 50%, the most likely projection is this green coloring here. That's in this yellow shaded percentile. So below, which is below median. Soil moisture. So here I have highlighted the 20-inch soil sensor and the 8-inch. So soil moisture has responded to early snow melt observed in late March and continuing through April. So with these maps, they don't fully capture the nuance. We're generally seeing good soil moisture conditions across much of the state. So particularly in southern basins, that's consistent with wetter conditions earlier in the water year, which helped improve runoff efficiency. One outlier is the South Platte, which entered the season with drier soils due to lower fall precipitation. So as of April 20th, we're seeing deeper sensors like the 20-inch in the South Platte now registering 138% of median. So suggesting moisture is percolated and into those deeper layers. In contrast, the 8-inch sensor for the South Platte is at 67%, so likely due to surface drying and faster infiltration or local soil texture. And then also it is, if you're looking at these soil moisture graphs on our IMAP, it is helpful to kind of zoom in and click on each basin. You can see any like larger nuances and disparities there. Like for example, in the San Miguel, I know that there's one sensor in particular, I think it might be Lone Cone, that has been having some erroneous data, so that can throw off those median and average values. So just helpful to click in to each basin there. But overall, moisture throughout the state is not too bad of standing, particularly in the southern half of the state. Okay, so moving on to reservoir storage. At the end of April was at 94%, or sorry, I'm so sorry, at the end of March was at 94%. So compared to 99% that time last year. On the left side here, I have a percent of capacity graph. And so we can see that overall basins are comparing pretty well for the April 1st this time of year compared to last year. The South Platte has a pretty significant difference. So this year we're at 68%. Last year, South Platte was at 82%. The headwaters 64% this year compared to 77% last year. And those are like the largest. Oh, the Yampa, White, and Little Snake were actually above 78% for capacity this year compared to 63% last year. And then panning down here, we can, that's an image of Colorado reservoir storage as a percent of median. So we can see that generally most basins are at normal, with the exception of the Eastern Arkansas, Eastern South Platte, and then the San Miguel the combined southwest basins are significantly below average here. And I can give you some more details there in the next slide. So here, the two larger capacity reservoirs are McPhee and Navajo. And so those are the two kind of bringing that median percentage down the most. So in below 80%, oh, here, I wrote it down. McPhee Reservoir storage capacities, 56% and 76% of median. And so that departure from normal is 64 thousand acre feet. For Navajo Reservoir storage capacities at 60% and 78% of median, and that departure is 161 acre feet. And that departure can be viewed on this graph here at the bottom. Navajo is the pink, and let's see, and McPhee is this yellow line here. So yeah, not quite at normal. This is the reservoir summary for the Gunnison. So similar data to what I just presented, it's just in a report format. This is also a new tool available on our NWCC apps page. So I have a QR code here. I'll just go through this really quickly, but this has the functionality to display snowpack precipitation forecast here. I just have reservoirs checked, and then you can look at data summary reports for each basin. And then if you scroll all the way to the bottom on this available basins list, there's statewide report summaries. So just another tool I wanted to highlight there. And then you can export this data in a couple different format options. All right. So stream flow forecast for April 1st, the median exceedance probability statewide is at 86%, and for March 1st, it was at 88%. Arkansas saw decline for March 1st, which is now at 87% compared to 92. Similar for the southwest corner, which is now at 60% compared to 63. Upper Rio Grande is now at 63 compared to 75%, which on March 1st. Gunnison, relatively unchanged, 86 from 87. And then the northern basins still near normal to above, or near average to above average, at 93% in the South Platte to 102 in the combined Laramie and North Platte. Okay, so here is the exceedance forecast probability chart for the San Miguel, Dolores, Animas, San Juan combined subbasins. And it's for April 1st. So this just has various forecast points in that basin and expected or forecasted exceedance probabilities. So 50% being the more likely. We can see the average highlighted here in these green points. So the 50% for all of these is, yeah, for all of them is well below that average. Okay, and so this is kind of similar to the forecast exceedance chart I just showed you on the previous page, except for it's just a more granular view for each forecast point. So these are our forecast evolution plots, also a new product. And I think they're helpful because you can look at the exceedance probabilities for the, since January 1st throughout, the whole forecast period. So January 1st through June 1st. Here I have highlighted McPhee Reservoir inflow, the primary for the primary runoff period, April through July. The bottom chart is for 2024. So the difference is that you can see the observed stream flow in this blue shading here. And in the bottom graph here, we can see how, that spread for this particular point kind of narrowed, or the spread wasn't as drastic when it got to June 1st. being as though that forecasters have more input variables by the time June 1st rolls around, they, with snowpack and precipitation and observed stream flow at that point, because we're in our observed period now. So yeah, just another tool just to help you can compare exceedance ranges starting from January 1st through the whole period. And I have a QR code here. Okay. So this is one of our snow to flow plots for the Dolores River at Dolores. I highlighted April 18th, so we can see that the black solid line is our current snow water equivalent. That dashed black line, which is plotted here on the right, is in Q, which is stream flow. They had an intersection here just recently, so we can see that early snowmelt, snowmelt has started a bit early compared to normal. And yeah, median snowpack is 10 inches, and observed snowpack is at 4.8 inches on that same time, so well below normal. Runoff median is the runoff median 712 CFS, or sorry, I'm so sorry, observed median is 712 CFS, and then observed flow is 712 CFS and median is 675. So a little bit above median here. Sorry, the colors are throwing me off a little. But anyways, these are helpful graphics just to see exactly, that intersection between snow water equivalent and stream flow, and how it compares to historical normals, which you can view with that shading. Yeah. Okay. This here I have highlighted a forecast evolution plot for the Navajo Reservoir inflow. So for April 1st, the 50% exceedance is 305,000 acre feet. And the 30-year median, and that's well below 30-year median, which is 630 acre feet. So, we'll probably likely expect some changes come May 1st here in a couple week or so, couple weeks. And then looking down below at the bottom of the screen, we have the Piedra River near Arbalest snow to flow graphic. This point is above Navajo Reservoir inflow. So I pulled this from a couple of days ago, last week, April 18th. So that intersection was approaching. We can see that's significantly well before median, with that solid green line and that dashed green line, which are after May 1st. So that was not only our snowpack levels below median, snowmelt is happening before expected median dates as well for this particular point, and in general in most of the southern parts of the state, in the Southwest, Upper Rio Grande, and Arkansas. Okay, this is the forecast exceedance chart for the Upper Rio Grande. So similar to the previous exceedance chart, 50% exceedance is in this green coloring here, which is highlighted in black in the center, and then the average, which happens to be well below average for all of these points. So just a reminder, in the more drier basins to consider this full suite, especially if we trend towards drier conditions. Maybe focus a bit more on like the 70% and potentially 90 or 95%, depending on which area you're looking at. Okay. This is a forecast evolution plot for the Rio Grande near, excuse me for just 1 second. Thank you. Just getting over a cold here. Okay, so I have a forecast evolution plot for the Rio Grande near Del Norte. This happens to be a higher runoff point, so I noted that one here. The 50% exceedance is estimating around 310,000 acre feet as of April 1st. On the bottom graphic, I have 2015 listed here. So yeah, you can, pull up whatever year of comparison you'd like on those evolution plots, and that can be helpful. So, for April 1st, for 2015, it was around 300 acre feet. And for 2015, the observed ended up being, 538 acre feet. Okay. This is another snow to flow for the Rio Grande near Del Norte. Again, current snowpack, that solid black line, well below median, that solid green line. And that dashed black line represents stream flow, also actually above median, surprisingly, but for, it's for this time of year, that's like indicative of early snow melt. So, which is why it's above median. We would typically expect a spike later in May, but we're seeing that now.
Hi, Nagam. Sorry, just to step in here. I just want to make sure we have time for our next presentation. So
yeah.
if you wouldn't mind just wrapping up in the next couple minutes, that would be great.
Yeah, I can do that for sure. Okay, so these next graphs are just similar to what I just shared, the forecast exceedance chart. So this is for the Arkansas. Yeah, definitely take a look at those. But yeah, similar story. Again, a forecast evolution plot for Pueblo Reservoir inflow. Actually, near normal. So some good news there. Pueblo Reservoir is at 109% of the 30-year median and 70% of storage. Median forecast or stream flow forecast is about roughly 300 acre feet. So close to normal, which is good. I'm going to zoom through the Gunnison here. But you all can take a look at these later. Again, yeah, normal or 50% exceedance here are not too far from normal. Yeah, so in summary, statewide snow water equivalent is roughly 80%. March brought increased storm activity. The end of March, we observed accelerated snowmelt statewide, particularly more pronounced in southern basins due to warming spring temps. Statewide water year precipitations at 94%. Statewide reservoir storage, 92% of median. So slight decrease, 8% decrease from this time last year. Soil moisture overall is showing pretty saturated soils in the southern part of the state, with the South Platte remaining as that outlier in the northern part of the state, likely due to the drier early season. Statewide stream flow forecast, a slight decrease from March at 86% compared to 88%. And that's all I have. Thank you.
Thank you. Thanks so much. I think there is a question in the chat, but maybe in the interest of time, you could reply just straight in the chat, and that would be awesome. And if anybody has questions, yeah, feel free to continue to put them in the chat. For our last 10 minutes, I will pass it over to Boyd, who is from the Colorado Division of Fire Prevention and Control, just to provide a brief wildfire update for the coming months. So I'll pass it over to you, Boyd.
Yeah, very good. Thank you. You got me okay?
Yeah.
Yeah. Well, thank you for being on the agenda today. Appreciated both Peter and Nagam's presentations. Used their products a lot. Really good overview for me for sitting in on that. So I do have a slide deck I will share, and we'll cruise through that. Are you seeing my slideshow?
Yes.
Okay. All right. Well, very good. I'm Boyd Labita. I'm with Colorado Division of Fire Prevention and Control. Sending regrets from Chief Jones and Director Morgan. We're not able to be in today, but I'll give it a go. I'll do a short overview on just how fire is managed, and then roll into the wildfire outlook stuff. So we're in the Department of Public Safety with these other groups: State Patrol, the Executive Director's Office, CBI, Homeland Security, and Criminal Justice. Involved in lots of things, robust training for local fire jurisdictions, primarily fire prevention, life safety, and then technology integration. We're working hard on trying to find new ways to apply the technology to give us a better perspective on the wildfires perspective. Involved in lots of things: planning, preparedness, and training, lots of response capability, a prescribed fire function, which is super important. We need to have a way to address fuel loadings and that are not just through wildfire occurrences, but we're configured to support local agencies, local jurisdictions, and counties. We're configured into 4 districts across the state in the 4 quadrants, and within each of those, we have what we would call a region with a local battalion chief that's the primary contact for the counties and the local fire jurisdictions. We provide lots of stuff. We've got staffed engines, we've got crew resources, we've got the federal excess property program. There's a fire equipment shop in Fort Collins that they can access excess military equipment and configure it into fire apparatus for loan to local fire jurisdictions. So lots of work to be prepared to respond to fires, and also robust aviation resources, air tankers, large air tankers, single engine air tankers, helicopter fleet, as well as the multi-mission aircraft intelligence gathering. So in Colorado, here's how wildfire works. We're a home rule state, of course, and by state statute, the county sheriff is a fire warden, and yet we all have fire districts covering most of the state. So that's the progression of how authority goes. So if a local jurisdiction's got a fire and it's exceeding their capability and exceeding the normal mutual aid, well, they call their neighbors to help them. They request that the county intervene, take responsibility of the fire, and then the same process happens as the fire escalates and the county is exceeding its mutual aid resources. They ask the state to assume the responsibility and costs, and that's all got a mechanism to happen. Fires never respect jurisdictional lines, so there's always an interaction with federal lands or other ownerships. And that's all done by the coordination of those people doing the management of that fire. And then, of course, it escalates back down once the fire conditions subside and suppression action is effective. As that becomes a less complex incident to manage, the responsibility can be transitioned back to the county and then ultimately back to the local jurisdiction. Of course, the state interacts with federal government in terms of FEMA grants, other interaction with federal agencies for management and payment of fires. So I'm going to keep rolling because I want to get to the cool wildfire stuff here. So I'm going to bounce through these things and get to this. So wanted to talk about the National Significant Fire Potential Outlook is a product generated monthly by the Predictive Services. Each of the regions in the U.S. contribute to this. And they do a monthly product. We're, of course, most of the way through April by now, but you can see I've shown the whole nation, but kind of looking in on Colorado, it's showing for April that southeast part of Colorado showing a higher than average potential, which fires are normal. But yet because of that, like Peter described, the April was a windy and pretty warm and pretty dry month. And we saw that especially on the 18th or 17th last week. We had a particularly windy day. If you remember that, we had Southeast Colorado had, sustained 30 to 40 mile an hour winds, single digit humidities. Grass had not really cured up, started to green up in lots of places. That was a very potent day. We were fortunate we didn't have fires go bigger than they actually did. Just rolling through that, they're also identifying June as for Southwest Colorado, which tracks really nicely with the information we saw on the precipitation and snowpack. We use that information and it gets built into this product as well. This slide, I just want to say it's normal to have fires. And also just that there's this tension, my last bullet point there, between this necessary ecological function of wildfires occurring, yet we've got lots of exposure and lots of complications on just letting fire burn. So we have the capability to respond, and we do respond and need to respond, but all the while knowing that there's another play out there that we've got this fuel buildup that really needs addressed. So anyways, you've seen this one. We love this. We view it as a indicator looking a little farther out because it's difficult to pin down the conditions or forecast the conditions. So this one is a good indicator for us just on what's coming. So great product. You've already heard the detail on it. Same with the drought monitor. We look at it that way. So drought and wildfires, eastern Colorado, where there's perennial grasses, perennial vegetation cover, we can certainly have fires. We can have fast moving fires that get really large. But as far as ecological damage or the typical post-fire negative effects, we typically don't see those, right? There's not enough loading to really damage the soil, not enough to cause hydrophobicity, those things. So we're not necessarily as concerned in general. But when we start looking at mountain systems, and like we're looking at Southwest Colorado for this year, when we don't have snow in the mountains, all the fuel profile's dry, right? The forest soils are a sponge and they absorb moisture when they burn. When they have some moisture, generally not that bad of post-fire conditions. But when we have the heavy drought and then we have aggressive wildfires, is the situation we would really love to avoid, and not only have an aggressive fire that's dangerous when it's occurring, but then having this potential for the post-fire negative effects that go on. So that's partly how we use the drought outlook. We have a dashboard. This is just a real short-term snapshot of what we would call fire danger on a given day. This is actually, I pulled it this morning on that, just giving us the sense of where we are today. So it's just going to reflect recent precipitation, recent high temperature, low RH kind of a perspective. But here's what I really want to get to is the seasonality of all this. Because in wildfire, it takes all these ingredients to happen. We've got to have the dry air. We've got to have no precip in a while. We've got to have available fuels. Then we've got to have a fire that be able to take advantage of those things. So it's very much an ingredient, and we can't really rely on a single thing to say that's going to tell us what's going on. So we have one discipline, I guess you could call it, is the fire danger side of things, and that's this pre-fire forecasting where we're looking out. So I'll talk about the wheel in a minute, but that's generally pretty coarse because we use a network of remote automated weather stations that are collecting the kind of data we can use to generate what is fire danger. Then when we get to a fire occurring, we can transition to a more specific fire behavior forecasting, but it's quite nuanced because nuanced things that influence a fire on a site are often smaller scale than we really can use our remote sensing tools that we do all these other things for to assess. So there's difficulties in both coarseness on the fire danger side and specificity on the fire behavior side. So the wheel is literally just a calendar year wheel for each of the RAWS stations that we reference. The metric in it is called Severe Fire Danger Index, and it's an overlay of energy release component, which just describes how dry it is. How dry is the wood and how dry are the shrubs that are going to burn. And then the burning index is a factor of combining that with the wind that occurs. And so for the climatology of a place, this example wheel is from the RAWS station at the Great Sand Dunes National Park. Windy, you can see it's windy in the spring, and that's in the San Luis Valley, but we can see it transition. So the blue is the lower condition, lower, but as we transition into later in the year, we can see that those conditions occur simultaneously more often. And as we've got fuels that are available, we can see that. So to me, it's a compelling way to view it, and also helps us describe different parts of the state, because looking at a statewide perspective isn't always that helpful from a wildfire perspective. We really need to know about the place we're talking about. I will point out that June, almost every one of the wheels we've got for RAW stations in Colorado has got a high proportion of severe and very high and high condition for June. That's just the way it is, right? The snow is all melted out. We don't really have precipitation occurring typically. It's hot. We have long days. It's pre-monsoonal flow for the typical climatology. So almost all of our charts, this is fascinating to me. Sorry if I'm nerding out about it, but June is really a key month for Colorado. Most of the really big wildfires we've had were in June, and with that very setup. Hayman in 2002, name one in 2012. 2020 was later in the year, but we had no monsoon that year. So anyways, let me get to this one. I can close out, Emily, if I'm running out of time here, but here's a little sampler of these that are from different parts of the state. So upper left is Willow Creek. You guys probably know where that is, up between Walden and Granby. Up there, blue most of the 6 months of the year, right? Because that's heavy snow country. And once that transitions out, you can see that summer is kind of a typical fire season. Upper right is Redstone, just on the west side of Horsetooth Reservoir, so the Front Range foothills. Similar, but obviously not a persistent snow cover, and we've got a little bit of that through January and February and March. You can see June again and July are potent, but then the fall, I want to point out for the Northern Front Range, it's typical for the fall to be dry and windy. Then we start getting wind events. So the fall is that condition. Lower left is Chapin on Mesa Verde National Park. Similar, not much going on in the dark winter months, but it's a little bit, you got to train your eye for this, but contrasting it with Redstone, the spring is more potent in the Southwest than the fall is there. And that's because it's like the rest of the Southwest US. It's windy in the spring. That's just the way the climatology goes. Snow melts out. We may or may not get a green up, and then we get that prominent June spike before the monsoonal pattern sets in. And then finally, the Ute Canyon is a RAW station south of Springfield down there, and it's a little more of a bullseye-ish shape, just because of no, there's really not a persistent snow cover there. It's just a function of when precipitation does occur and how long it can stay and how long it can be effective. So it kind of the illustration of, Colorado, just it matters a lot where we're talking about and where we're trying to forecast fire behavior for. So I have no idea what time it is. And I'm sorry if I've gone really long. I will close it out there. But I'm happy to answer any questions if there are any.
Thank you so much, Boyd. That was a great presentation, and the visualizations, the wheels are a nice visual tool. So thank you for showing us a few of those.
Okay.
How many of those? I know we're 6 minutes over, but I just have a quick question. How many of those, I guess, sensors or wheels do you have?
Well, there's we've built around 73 of those.
Okay, gotcha.
There's probably in the low hundreds in terms of the raw stations that would be eligible
Okay,
would have sufficient data to do that. Unfortunately, there's relatively few of those on the eastern plains of Colorado, just because our raws, we just don't have the years of data to build a really nice climatology with those.
gotcha.
But I'll share the draft. I see a question that are they available? They will be. We will be attaching them to, I showed you the picture of the current fire danger slide. That's a dashboard from our graphic or from our dashboard. And we're going to be making the wheels a pop-up with each of the raw stations. So that I don't have
Awesome.
that today, but that is coming. And so we'll be working on that.
Awesome. Thank you so much, Boyd. And thank you, Nagam and Peter. Thank you all for staying on 8 minutes over. We just had a lot of great information today. So I will end today's meeting. Our next WCMC meeting will be in May. Let me pull up the date. I believe it is May 20th. So I will see you all then. Thank you.
Very good. Hope that was all right, Emily. Was that?
Yep.